This will be lesson 4.1, talking about unit rates. Okay, for unit rates, we have an objective I can find and use unit rates. And our standard is RP1. Compute unit rates associated with ratios of fractions, including ratios of length, areas, and other quantities measured in like or different units. Minimize myself, and let's begin. So what is a rate? Talking about rates and proportions and percents for a bit here. So a rate is a special ratio in which two terms are in different units. So a ratio is another word for a fraction. You could see a ratio written as, let's say, 4/3 might be a ratio, or you could see it written as 4:3, which means 4:3. So you can see ratios written either way. We're going to deal mainly with fractions. For example, miles per hour is a rate with a term for miles and a term for hour. They're different units. This means that after so many hours, a car will have driven a set number of miles. So if a car drives at 60 miles per hour, that means it will travel 60 miles in 1 hour of time. So how far do you think the car is going to travel after 2 hours? If it goes 60 miles in 1 hour, how far will it go in 2 hours? Did you say 120? Excellent. So rates can be written as fractions. Here's 60 miles in 1 hour. Okay, that's rate, writing it as a fraction. And it's a good idea with rates to include the unit so that you know what you're dealing with and you can set up your proportion properly. So 60 miles goes on the top, 1 hour goes on the bottom. There's other ways to set them up, but you want to keep certain things together. So after 2 hours, 120 miles, right? You could figure out after 3 miles or 3 hours, that would be another 60 miles. And after 4 hours, another 60 miles again. So let's take a further look at this. So what is a proportion? I just mentioned proportion. So a proportion is a statement that two rates or ratios are equivalent. Equal. Equivalent, remember, means to equal. So in our car example, we can write proportions based on the rate of 60 miles per 1 hour. There's our 60 miles per 1 hour. That's our rate written as a fraction. And we can set that up as a proportion. That's the same as 120 miles in 2 hours. Or the car would go 180 miles in 3 hours. Or the car would go 240 miles in 4 hours. So it's adding 60 miles every time an hour increases. So that is a proportion, equivalent proportions. Proportions can be used to solve rate problems, and that's the method I'm actually going to be using with you guys. So let's see how rates work. So Maya hikes half a mile every 15 minutes. Half a mile every 15 minutes. And Anaya hikes 1/4 of a mile every 10 minutes. Okay, so we have different rates. Maya's walking rate is different than Anaya's walking rate. How far do they each hike in 1 hour and then in 2 hours? Well, let's take a look. How do we figure this out? Step 1, we're going to set up a table for each girl. So let's start with Maya. So we're going to make a table. So time is our independent variable down here. That's our x. Later on, we're going to be knowing x and y a little bit more. But for now, know that the independent variable is x. When you're independent, like when you're independent from your parents at some point in your life, that means that you are on your own, right? You don't depend on them anymore. You can make your own money, you can buy your own food, you can live in your own place, you can drive your own car, you have your own job, you are independent. So time is always an independent variable because it doesn't depend on anything else. Time just keeps happening and happening. And then distance, in our case, is our dependent variable. So the distance that Maya hikes is dependent upon how much time has gone by. So that's why distance is the dependent variable. It's also called y, the dependent variable. So let's take a look at how we make our chart. And there's Anaya's chart. Same thing. We'll have time as x and distance as y. So just looking at Maya's chart first. So Maya hikes half a mile every 15 minutes. So how far does she go in 1 hour and 2 hours? So we're going to change, first of all, our decimal 1/2. We're going to change that to 0.5 or 0.5. How do I know 1/2 is 0.5? Well, you should memorize that, first of all. But second of all, if you wanted to prove it to yourself, you would take 1 and divide it by 2. Put a decimal point in a 0. Put your decimal up here and say how many 2's go into 10? 5 times, right? And 2 times 5 is 10. 10 minus 10 is 0. So that's where I'm getting the 0.5. So 1/2 is equal to 0.5. Now I'm going to clear that. Let's continue on. Step 2, we're going to set up a fraction with the rate given in the problem, 1/2 of a mile to 15 minutes. And then we're going to solve for what we are looking for. So let's see how that looks. So we're going to set up 0.5 of a mile over 15 minutes. Notice how I'm putting the label by it as well. So I remember the 0.5 is the same as half. We're going to set that equal to our proportion. So we want to know how far she goes in 1 hour. And I know how many minutes are in 1 hour. There are 60 minutes in 1 hour. So I'm going to do, trying to get my spotlight there. I'm going to do 60 minutes instead of the 1 hour because my 15 here is in minutes. Notice how I have minutes across from minutes. And I'll have miles across from miles. I have an X here because that's the number we're trying to find right now. We want to know how many miles she walks or hikes in 60 minutes. So on the top here, we're looking for miles. So miles on the top has to match miles on this top. Minutes on the bottom has to match minutes on this side. So they have to go together. So we're going to cross multiply and divide. So what do I mean by cross multiply? Well, I diagonally multiply the two numbers that are across from each other diagonally. Now you're going to be using a calculator for this unit. So you're welcome to go ahead and type on your calculator 0.5 times 60. I can do that here for you. This is a pretty easy one, but some of the ratios will get a little bit bigger. So you're going to want to have your calculator available. I would rather you know what you're doing more than having to stress out on the calculations. 0 times 5 is 0, and 5 times 6 is 30. We have one number after the decimal, so 30.0. So if I multiply 0.5 times 60, I get 30.0 or just 30. So 0.5 times 60 is equal to 30. Then the second part is to divide by the number I haven't used yet. So I cross multiplied these two, and I have yet to use the 15. So now I'm going to divide my 30, the answer I just got when multiplying, and I'm going to divide that 30 by 15. So 30 divided by 15, you can do that with your calculator, or you could do it with your pencil if you wanted. That will give you 2. So that is my answer. So Maya will hike 2 miles in 1 hour or 60 minutes. Okay, now let's do the 2 hours. Okay, so we got the same ratio, the same rate, 0.5 miles to 15 minutes, and now we're going to put 120 minutes on the bottom. Why did I pick 120? Because 2 hours is equal to 120 minutes. My minutes have to match my minutes. If I wanted to do hours, I'd have to convert 15 minutes to 1/4 of an hour. And I could do that if I would prefer, but I'm going to use minutes. So now I have to cross multiply 0.5 times 120. That'll give me 60. And then I divide by the number I haven't used. I haven't used 15. So I'm going to divide 60 by 15. And that will give me 4. So now I can fill in my chart. Fill in the table. So we have a 2 and a 4. So our time is 15 minutes. Put that in there. And our distance is 0.5 miles. Okay. Then we have our 60 minutes. And that equals 2 miles. Okay. And then our last time is 120 minutes. And that equals 4 miles. So that's how far she goes in 2 hours, 4 miles. Okay, we've done that for Maya now. We've made a chart. Now we need to do this for Anaya. Here's Anaya's chart. Let's do the same exact thing. So Anaya hikes 1/4 of a mile every 10 minutes. So how far does she go in 1 hour or in 2 hours? Let's take a look. So first I'm going to change 1/4 to a decimal of 0.25. How do I know 1/4 is 0.25? Well, you should memorize it, but if you don't know it, you want to know where it comes from, you're going to divide 1 by 4. Put the decimal point in a 0, the decimal point up here. 4 goes into 10 twice. 2 times 4 is 8. You guys should be kind of familiar with doing this from our last unit. 10 minus 8 is 2. And then I'm going to bring down another 0. And then 4 goes into 25 times. And 4 times 5 is 20. And 20 minus 20 is 0. So that's where I'm getting this 0.25. So 1/4 is equal to 0.25. Now that we've known that, let's continue. Step 2, we're going to set up a fraction with the rate and cell for what we are looking for. So, and then we're going to cross multiply and divide. So 0.25 miles over 10 minutes. Notice how the rate is different from Maya because Anaya has a different rate. And now we want to figure out how much she walks in 1 hour. Well, 1 hour is the same as 60 minutes. Notice again how I have minutes across from minutes, and I'm looking for miles. So miles goes across from the other miles. Now I'm going to cross multiply. What am I cross multiplying? 0.25 times 60. So I put that in my calculator, or I figure it out with paper and pencil, and I get 15. Then I'm going to divide my 15 by the number I haven't used, the 10. So 15 divided by 10 is going to give me 1.5. So Anaya walks 1.5 miles in 1 hour. Now we have to figure out how far Anaya walks in 2 hours. We set up the same initial proportion, 0.25 over 10 minutes equals something over 120 minutes, because 60 minutes plus 60 minutes is 120 minutes. That's 2 hours. I cross multiply 0.25 times 120, and that'll give me the answer of 30. And then I divide by the 10 minutes, and that will give me 3. So in 2 hours, Anaya walks 3 miles. Let's fill that out in our chart. So 10 minutes goes in time, and 0.25 miles goes in the distance. Then we do the next one, 60 minutes goes in the time, and 1.5 miles goes in the distance. Then we do 120 minutes, that goes on the time, and 3 miles goes in the distance. Okie dokie, so far so good. Okay, here's our charts all filled in for us, comparing Maya to Anaya's rate of speed. So notice how Maya will be going 2 miles in 1 hour, and Anaya is going to be going 1.5 miles in an hour. Maya will have gone 4 miles in 2 hours. Anaya will have gone 3 miles in 2 hours. So let's take a look. So, does Maya or Anaya walk faster? Who's walking faster? Did you say Maya? Why did you say that? Yes, because Maya will have walked 4 miles in 2 hours, while Anaya will only have walked 3 miles in 2 hours. She might be taking her time a little bit more. So see how rates work? Okay. Maya walks at a faster rate. All right, you get to try one of these type of problems. See you back in a moment. Pause the video. Okay, welcome back. Hopefully you did your questions. Let's continue. What is a unit rate? A unit rate is a fraction where the denominator, that's the bottom number, is 1. So if the car drives at 60 miles per hour, mph, miles per hour, this means it will travel 60 miles in 1 hour of time. That is the unit rate. Miles per hour is a unit rate because there's a 1 on the bottom. If we were talking about Maya, she was able to go, what was it? How far did she go in 1 hour? Let's go back for just a second here. I'm going to pause and let's go back. Okay, I just wanted to go back and look at this chart again for a minute. So the 60 minutes, get my annotation back. The 60 minutes here is your 1 hour, right? So our unit rate for Maya is 1 hour on the bottom and 2 miles on the top. For Anaya, 1 hour on the bottom is 1.5 miles on the top. So those are the girls' unit rates. This is Maya's unit rate. This is Anaya's unit rate. Okay, I just wanted to clear that up for you and see, so you could see another example. Okay, let's go back to the next page again. Okay, so the unit rate is where the bottom number is a 1. Okay, this is a unit rate because the denominator equals 1. And we just showed you with Maya and Anaya what their unit rates were. So let's find some unit rates. Okay, so while remodeling her kitchen, Angelina is repainting. She estimates that she paints 55 square feet every half hour. How many square feet does Angelina paint per hour? That's going to be a unit rate because we're trying to find how much she paints in 1 hour. Okay, so we got to use our proportions. So we're going to put 55 square feet on top, and we're going to put 0.5 of an hour on the bottom. Why did I put 0.5? Because I have half an hour, and we decided that 1/2 was equivalent to the decimal 0.5. Now let's set up our second part. We're going to keep hours with hours. They have to stay on the same bottom together. And then on the top, we're going to have square feet. So we're looking for the question we're looking for is how many square feet. So square feet is our missing variable and square feet on this side. I used Y instead of X because I wanted you to see that we're looking for the dependent variable. And Y is always called the dependent variable. So square feet depends upon how many hours have gone by. So if she is painting, she's going to paint more square feet the more hours that go by. So we're going to cross multiply and divide. 55 times 1, divide that by 0.5 of an hour. So 55 times 1 divided by 0.5, the number that remains. Take your calculator and you get 55 on top and 0.5 on the bottom. Then you go 55 divided by 0.5 on your calculator, and you should get, well, I'm actually doing it over here for you. So we have 0.5 divided by 55. We have to move our decimal to get rid of it on the outside number. Here we did, we moved it to the end. So we have to do the same with the inside number. So it's assumed to be after the number. We're going to move it there and fill in with a 0 with the empty space. Then we're going to have 5 divided by 550. 5 goes into 5 once. 5 minus 5 is 0. Bring down the 5. 5 goes into another 5 one time. 5 times 1 is 5. 5 minus 5 is 0. And we still have to bring down one more 0. 5 goes into 0 0 times. 0 times 5 is 0. 0 minus 0 is 0. 110. So that is our answer. Angelina can paint 110 square feet every 1 hour. So this is your Y. This is our missing Y value. Okay, how many do you think she could paint in 2 hours? If she can paint 110 square feet in 1 hour, how many can she paint in 2? Right, you'd add 110 plus 110, or you would times 110 times 2. That would be 220. So in 2 hours, she would paint 220 square feet. Okay, that's how these rate problems work. What? Where's my problem? Oh, okay. Paige mows 1/6 of an acre in 1/4 of an hour. How many acres does Paige mow per hour? 1/6 of an acre in 1/4 of an hour. Okay, let's first set that up. Ignore the right side for the moment. So we have 1/6 of an acre over 1/4 of an hour. We're trying to find the unit rate, remember? So Y is going to be the acres that we're trying to figure out. How many does she mow in 1 hour? So the hours are next to each other. The acres will be next to each other. So now I'm going to do cross multiply 1/6 times 1 hour and divide by 1/4. So 1/6 times 1 hour is just 1/6, isn't it? Yes. So, I put it down there. Okay, so 1/6 times 1 on the top divided by 1/4 of an hour on the bottom is equal to 1/6 on the top divided by 1/4 on the bottom. And now I go to the thing that popped up too soon. So now I'm going to divide. So I have 1/6 divided by 1/4. The bottom number, it means division, right? Fraction is a division problem. So 1/6 divided by 1/4. Now I use keep, change, flip. So I'm going to keep my first number, a 1/6. I'm going to change the sign to multiplication, and I'm going to flip 1/4 to the reciprocal, which is 4 on the top and 1 on the bottom. And now I'm just going to multiply. 1 times 4 is 4. 6 times 1 is 6. Now I have 4 over 6. I can reduce that, so I'm going to divide 4 by 2, and I'm going to divide 6 also by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So how many acres does Paige mow in 1 hour? She mows 2/3 of an hour. An acre. So Paige mows 2/3 of an acre, goes right here, in 1 hour. That's her unit rate. Okay, so you can use fractions to do this as well. Okay, you get to try a problem like this, or maybe 2, and come back. Pause the video. All right, welcome back. Let's continue. You can use unit rates to simplify rates and ratios. So here we have 2 pools are leaking. After 15 minutes, pool A has leaked 2/3 of a gallon. After 20 minutes, pool B has leaked 3/4 of a gallon. Which pool is leaking faster? This is very similar to the Maya and Anaya problem. It's just instead of hiking speed, it's going to be leaking speed. Hiking to leaking. Let's do pool A first, just like we did Maya first. So after 15 minutes, pool A has leaked 2/3 of a gallon. That is going to be the rate we set up. 2/3 of a gallon will go on top and 15 minutes will go on the bottom. Let's set that equal to what we're missing. We want to find the unit rate. So the unit rate is 1 hour. 1 hour is the same as 60 minutes. Why did I use 60 minutes instead of 1 hour? Because I used minutes over here. So minutes have to match minutes. If I wanted, I could change 15 minutes into 1/4 of an hour and use that. And then I could write 1 hour over here, because then I'd have hours matching hours. So it doesn't matter either way. If you like dealing with fractions better, you could do that. I'm going to deal with minutes. So now I'm going to cross multiply and divide. So I'm going to cross multiply 2/3 times 60, 2/3 times 60, and then I'm going to divide by the 15. So what is 2/3 times 60? Well, if you were trying to do that, you would do 2/3 times 60 over 1. You can always put a 60 over 1. Then 3 will go into 60 20 times, because 20, 40, 60, and 3 will go into itself once. So 2 times 20 is equal to 40. And on the bottom, I have 1 times 1, which is just 1. So 2/3 times 60 is going to equal 40. So let's pop that up. So 2/3 times 60 equals 40, and we're going to divide by the 15 minutes, the number we haven't used yet. Wait for that black bar to go away again. Okay, so let's do 40 divided by 15. 40 on the inside, 15 on the outside. So how many 15s go into 42? You can do the calculator if you want. 15 times 2 is 30. 40 minus 30 is 10. I'm going to bring the 10 up here. I don't have to. I could make it a decimal, but I'm going to bring the 10 up here. And then 15 will stay on the bottom as my number. 2 and 10/15. Divide the 10/15 by 5 to reduce it, and I get 2/3. So 2 and 2/3. So pool A leaks 2 and 2/3 gallons every 1 hour, or every 60 minutes. That is our unit rate for pool A. Okay, pool B, same deal. So pool B, after 20 minutes, pool B has leaked 3/4 of a gallon. Set that up. 3/4 goes on top. 20 minutes goes on the bottom. What are we looking for? We are looking for gallons, right? So how many gallons leak after 1 hour, or 60 minutes? Again, if you like fractions, you can change 20 minutes into a fraction and 60 minutes into 1 hour. I'm going to use minutes. So we're going to cross multiply and then divide. So we're going to cross multiply 3/4 times 60 and then divide by the number that's left, the 20. So to figure out 3/4 times 60, I kind of have to write it on paper. And by the way, you should be using paper to get your scratch work done. Don't try to do everything in your head, because it's important to see what you're writing. Okay, so now I can cancel out 4 into 60. 4 will go into 60 15 times, and 4 will go into itself once. So I'm really multiplying 3 times 15 on the top, which would give me 45, and 1 times 1 on the bottom, which would give me 1. So 45 is the top answer, 3/4 times 60. That should pop up there. So 3/4 times 60 is 45, and now I have to divide that by 20. So 45 on the inside and 20 on the outside. How many 20s go into 45? 2, right? 2 times 20 is 40. 45 minus 40 is 5. Bring the 5 to the top. That becomes my numerator. My denominator stays at 20. And then I reduce 5/20. Divide top and bottom by 5. And I get 5 divided by 5 is 1, and 20 divided by 5 is 4, so 2 1/4. So pool B leaks 2 1/4 gallons every 1 hour for every 60 minutes. So now let's compare pool A to pool B. Now that we figured that out, which pool is leaking faster? Pool A leaks 2 2/3 gallons every hour. Pool B leaks 2 1/4 gallons every hour. Which one's leaking more gallons? Which is bigger, 2 2/3 or 2 1/4? What's the bigger number? I hope you think 2/3 is bigger than 1/4, right? So 2 2/3 is greater than 2 1/4. So pool A is leaking at a faster rate, so it will be empty sooner. Okay, try a problem like this. See you back in a minute. Okay, welcome back. Let's talk about focusing on higher order thinking. So we have a package that costs, well, we have a 10 pack of bars and a package of granola bars that cost 2.1 ounce, 10 bars that are 2.1 ounce per bar. They cost $15.37. Then we have a 12 pack package that is 1.4 ounce bars that cost $15.35. So the bars are smaller, but there's more in the package. So what are we going to figure out? Which package has the better price per bar? Okay, so 10 pack is $15.37. That's the cost divided by the 10 bars in the box. We're going to figure out what the cost is per 1 bar. That's our unit rate. Cross multiply and divide. $15.37 times 1 divided by the 10 bars is $15.37 divided by 10, which is $1.53. You can do that with your calculator, or you can know that whenever you divide by 10, you move your decimal 1 place to the left. So I move the decimal, it's going to probably put the black box there. I move the decimal 1 place to the left. So that the first box, the blue box, each bar costs $1.53. Okay, let's do the 12 pack box. So the 12 pack box costs $15.35 a box, and there's 12 bars in a box. So set up a proportion. So how much does it cost for 1 bar? Cross multiply and divide. $15.35 times 1 divided by 12 equals $15.35 divided by 12. Use your calculator or do it here. You get 1 goes into 15, or 12 goes into 15 1 time. 15 minus 12 is 3. Bring down the 3. 12 goes into 33 how many times? Twice. 2 times 12 is 24. 33 minus 24 is 9. Bring down the 5. 12 goes into 95. Ooh, that's a big one, right? 7 times 84. And that leaves me with 11. So I don't have to go farther than that because I'm talking about money. So it's about $1.27 a bar. So it's about $1.27 a bar. Okay. So which package has the better price per bar? Well, the 12 pack, right? You're paying only $1.27 per bar versus $1.53 per bar. Okay. Let's do it a little differently. Which package has the better price per ounce? So which one are you getting more from, right? You might be getting a better price per bar in the 12 pack, but are you getting a better price per ounce? So we're going to set up the same kind of a unit rate thing. 2.1 ounce bar size times 10 bars in a pack. That total package, the blue pack, has 21 ounces total of food in it. Okay. So we're going to set up the cost again, $15.37. This time on the bottom, instead of number of bars, we're going to put 21 ounces. That's how much ounces of food is in that box. And we're going to figure out how much it costs for 1 ounce, our unit rate. Cross multiply and divide by 21. 15.37 divided by 21 equals 73 cents per ounce for the 10 pack box. So Costs 73 cents per ounce. Now let's do the 12-pack box. So the 12-pack box, we have to figure out how many ounces are in that. Well, each bar is 1.5 ounces, and we have 12 bars in that pack. So multiply that. You get 16.8 ounces in that box. Set up a proportion. That box costs $15.35 divided by 16.8 ounces in the box. Set that equal to Y over 1 ounce. How much does it cost for 1 ounce of food in that box? Cross multiply 15.35 times 1 divided by 16.8. That's the same as 15.35 divided by 16.8. Put that in your calculator. You should get 91 cents. So it costs 91 cents an ounce in the 12-pack. So which one is the better deal? Well, the 10-pack is the better deal when you figure it out per ounce, right? The 12-pack was a better deal when you figured it out per bar. So I'd rather get more food than more bars, right? So I think the better deal is the 10-pack is $1.53 a bar, $1.27 a bar for the 12-pack, and the 10-pack costs 73 cents per ounce, and the 12-pack costs 91 cents per ounce. Comparing those, I'd rather have the better deal per ounce. So if you want the most ounces for your money, choose the 10-pack box. Awesome. Okay, you get to try one of these type of problems. Okay, welcome back. Your homework is on Google Classroom, and I am done for the day. So I'm going to say adios, amigos. Have a good day. Bye.